I made this quick video to try to get you guys through this problem. It is a toughie problem, I'll tell you right off the bat. But here, let me show you what I came up with. So this is Chapter 9, Problem 16, the linear programming, trying to minimize the cost. Okay, and I give you a lot of data. Forest fire. It's burning in a valley 3 miles wide. It goes 40 feet per minute. So they're going to cut a fire break across it. So one fireman can cut 1 foot of fire break for every 30 seconds. The value of the lost timber is 4,000 per square mile. Each person hired is paid 18 bucks an hour plus $50 to transport them. Okay, so I like its advice. It says draw a picture. So that's what we're going to do. Okay, so basically we're going to do is we're going to try to milk out every kind of equation we can from the data they just gave us. Okay. First picture, there's a valley. It's 3 miles wide, 15,840 feet. I don't know if it's going to switch from miles into feet, but we're going to have to watch the units here, like hours into minutes, miles into feet, but we'll just play it as we go. What else do we know about that valley? That there's a fire, and it's going 40 feet per minute. So the firemen have to come in and build a fire break. A fire break is where they come in and they either chop down all the trees or burn them down before the real fire gets there, so the forest fire cannot jump across. That's what a fire break is. So what else do we know? We know that one fireman can cut 1 foot in 30 seconds, which is the same as 2 feet in a minute. I think we're just going to use the 2 feet per minute one. And then the amount of money is $18 per hour plus $50 transportation fee for each one. And trees cost 4,000 per square mile. Okay, let's milk as many linear equations as we can out of this data. Equations. Okay, so first of all, how many firemen are we going to need? Good question. So we're going to let the letter capital F equal the number of firefighters, right? So the letter F means the number of firefighters that are going to be hired. It's an unknown, it's a variable, right? But we do know that one fireman can clear 2 feet in 1 minute. So F firemen can clear F times 2 feet per minute. Got it? So the fire break, let's jump over to that one. So we're going to let the capital letter T represent the number of total minutes it takes to clear all the fire break, regardless of how many firemen. I'll say that again. The letter T is in the number of minutes to clear the entire fire break, regardless of the number of firemen. To figure that out, you got to remember that distance equals rate times time. We do a little algebra there. We got rate equals distance divided by time. We have time equals distance divided by r. That's the one we're going to use. You guys get used to this formula. It's used a lot in these problems. Okay. So the time is going to take the distance divided by the rate. Okay, and we broke it down here. The total number of feet across the valley, which was 3 miles, divided by the rate is the rate of the firemen and their fire break ability, their speed, okay? So 3 miles, I changed it into feet, is 15,840 feet divided by 2 times F. Remember, big F is the total number of firemen with the feet per minute unit, okay? So this boils down to, right, the feets cancel out. It boils down to 7,920 divided by F minutes. That's how long it's going to take to build the fire break. Fire break taken care of. Next slide. Fire speed. We kind of know how fast that's going. That's a pretty easy one. The velocity, we'll let the capital letter V equal the velocity of the fire, and we know it's traveling at 40 feet per minute. That's pretty fast. So again, I'm not sure if we're going to be using miles or minutes. I'm hesitant about sticking to one. It'll probably be minutes, but I'm not 100% sure. But we have the formula, we have the equation to calculate the velocity of the fire. Okay. So here comes a hard one. We have the calculate D. We're going to let the capital letter D equal the distance between the fire and the fire break. Got it? Let me show you that picture again. So D is going to be the distance between the fire and the fire break. Okay. And again, we got to remember that distance equals rate times time. So D, right, the distance between the fire and the fire break is going to be the rate of the fire, which we know is 40 feet per minute, times the time it's going to take to clear the fire break, which we calculated already. We calculated T, we calculated V. So V we know is 40 feet per minute times T, and T was this one, right? 7920 divided by F times the number of feet per mile in a mile. Okay, so we're still calculating D, right? So we have all the values listed out here. We're just going to have to multiply it out. So we're going to multiply 40 times 7920. That equals 316,800. And we're going to divide that by 5280, the number of feet into a mile. We're going to leave the F where it is. But 316,800 divided by 5280 comes out to be 60. So our distance between the fire break and the fire itself is only 60 divided by F. Remember, F is the total number of firemen. Okay, moving on. We're going to let A equal the area of the forest that has been burned by the fire during time T. Okay, so A is the total number of square miles of burnt trees in the T time that it's been burning. So the area is the width of the valley, which we know is 3 miles, times the distance between the fire and a fire break. That's what this distance is, okay? So area equals 3 miles times D, and D we just figured out. It's 60 divided by F. And we put everything we left it into square miles here, right? 3 times 60 is 180. And that's square miles divided by F is the number of firefighters again. Okay, so now we have the area. A few more to figure out here. Let's let the capital letter C represent the total cost of the burned trees. So that's what, however many of the trees burned down, this is going to be the cost of the burned trees. So we know that the trees are costing $4,000 per square mile, and we're going to multiply that square mile times the number of square miles of the area of the burned trees. Okay, so again, it's going to be $4,000 per square mile times the area of the burned trees. Okay, so we have this already calculated out, right? A we just calculated 180 divided by F, and C was given, and so that comes out to be a grand cost of $720,000 divided by the number of firefighters. And your labor cost, okay? So the labor cost, we're going to let that be L, is the total number of firemen times their pay rate plus that extra $50 to deliver each one. So the firemen were making $18 an hour times hours and minutes. Again, I wasn't sure if we're going to use hour or minute, so we might have to switch the hours to minutes, but I just left that in there. Times T. Remember, T was the total time it would take from the fire to get to the fire break, plus 50. And that boils down to 0.30 times of F, which is the total number of firemen, times this one. This is the T, right? 7920 divided by F plus 50 times F, right? We just distributed this F to everybody inside the parentheses, and we got the total labor cost just to be 2376 plus 50 times the number of firemen. And pretty soon we're going to lump all these together and just come out with one total cost. And there it is right there. So the total cost is going to be total labor cost plus the cost of the burned trees, okay? So the labor cost we just figured out was 2376 plus 50F plus the cost of the trees. We did that too, okay? So this is your big formula for the total cost. Now I pulled out what I think is going to be the main formulas, and it's definitely going to be the total cost because we want to minimize that. And I put the distance ones up there because I wasn't sure. So, but now let's go to our Excel. So you'll notice I put down a total cost formula here just so I can type it in. So I'm gonna type that formula into this cell, but before I do that, I'm gonna put a value into this F so I don't get an error. Okay, I'm just gonna pretend that we're gonna start with 10 firefighters. All right, carefully click that cell, type in equals, and then go to town. 2376 plus 50 times, right, shift 8 times our cell here, right, then another plus, and then we want parentheses. We want 720000 divided by this cell again, close parentheses, and that should work here. Bam. Good. And then for the total distance of the fire break, it's simply 60 divided by F. So again, we're going to pick that cell. We're going to go equals, and then we're just going to type in 60 divided by whatever F is again. So good. So what I'm going to do is I'm going to start changing the F. I'm just going to do them by increments of 25. See what happens. 50, 100. Hold on while I pick some good values here. So I put some values in there going by counts of 25. Towards the bottom, I just put in counts of hundreds. But now you should see something in the total cost of pattern. It should start getting really small somewhere in there. So what we're going to do is highlight these two and then just drag them down. It's going to copy the functions in there, and it's going to switch over the F values. Okay, so it looks to me like we want to minimize the cost. It's going to be somewhere in this area right there. You guys see that? It's down to under $15,000. And if I had to be more specific, I would say it's probably going to be somewhere between 100 and 125. Probably real close to 125 somewhere. Okay, so here's the bad news. This is as far as I could take it. Okay, so I know that the solution is going to be somewhere around 125. Okay, and I, for the life of me, cannot figure out how to do the solver. I keep getting the same error message. I don't want to beat you guys to death with this, but let me show you what I did. So I'm not very good with solver. This is going to be your homework assignment. Figure out solver and teach it to me. So we're going to go to data. We're going to go to solver. Remember, if it's not there, you're going to have to go to file, options, and then add it in. Okay, I'm not going to do that here, but we're going to go to solver. Okay, the first thing is your objective cell. This cell has to have a formula in it. So I'm just going to pick one, okay? I'm going to pick this cell because it has a formula in it, okay? And this is what I want to minimize, right? So that part's easy. The cells you're going to change by the variables are these F values. We don't know where the perfect number is, so that's what's going to be ranging up and down. So we're going to, let me take these out because they just confused everybody. But you're supposed to set some constraints. Maybe that is where I'm making my boo-boo here. Hold on a second, delete that guy. So the constraints of the cells are, the only one I could think of is this cell, right? These cells, they got to be greater than 1. That's the only thing. Greater than, where's my greater than? Greater than, right? 1. Right? We don't want negative numbers, and I know 0 ain't the right answer, so that's the only constraint I can think of. I put that in there, and every time, make sure you're in simple linear regression, simplex, and then you click the solve button down here, and I always get this same error message. So this is where I get stuck. And I'm done working on it. I've worked on this stinking problem for over 2 days now. So I hope this helps. So again, your homework assignment is try to figure out how to get the answer from the solver. I'll go ahead and put that in there because I have it. Hold on a second. So here's the answer from the answer book and I have no idea. I can't figure out how to get it to work. And I watched every one of those videos. I must have watched 10 different videos on YouTube. This is a minimized problem. Most of those in there are maximized problems. There are some minimum problems in there, but for the life of me, I could not figure it out. I don't know where I'm making my mistake. So again, last time is If you guys can figure it out, please let me know. I'll give you super duper extra credit. But that's it. MGZ out.